start with question number 8 on part 2. Actually, no. Let's go to question number 9. And I think if we go through this, this will help us get through the quiz much faster.
Yeah, I think you're right. Sorry.
Okay, question number 9. 7% is the true unknown percent of the population do not have traditional phones and instead rely on cell phones, so 7% is P. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, which is 8%, in this survey will use only cell phones? So, what is the mean? So we have to take, the mean is 7%, right? Or 0.07. And the standard deviation, to get that, we need to take the square root of the sum of 0.07 times, in parentheses, 1
minus
0.07, right? And then divide that by 750. And that is how we get the 0.0099. Any questions on that? Monica, do you get that?
Yeah.
Okay, so that is our standard deviation.
And that's what they
said. So state the problem in terms of the variable p hat. So p. Okay, so the p hat is okay, does anybody have questions on that?
Wait, just a second.
Well, I guess it makes sense. They didn't really talk about that particularly in the video, but it makes sense.
Yeah, so the P
is going to be the probability of the 60 phone users.
Right. 60 over, so P hat is 0.08, right?
Yeah, so 60
over 750.
The 750, yeah.
Okay.
On the answer key, why did it say greater than?
Because that's what the question asked up in the here. Suppose a random sample of 750 telephone is obtained. What is the probability that more than 60 phone users, or 8% in this survey, will use?
I didn't see that. All right.
Okay, so draw a picture of the desired area. Okay, so then let's turn the page and go to the next one. You should have a normal curve with the area in the right hand. This is just conceptual since you won't really actually do this until the next problem. Okay, convert or standardize the value of p hat using the standard normal variable z, finding the z score.
And that's that whole, that would be
0.08.
0.08 minus
0.07
over the
standard deviation, which is 0.0093.
What?
Our standard deviation is 0.0093, right?
Yeah, we already found it, so we don't.
0.099, wasn't it? Yeah.
Oh yeah.
Oh yeah. I think you're right.
You never want to talk.
Yeah, 99. When I did the math, it was 93. That was my bad. 99. Okay, so our z score is 1.073. Do you get that?
Yeah. Let me try it really fast. Make sure I'm doing this right.
And you are so fine.
I'll put it in.
So what did you get?
Z equals 1.073.
Oh, that's not what I got. Is that what they got?
Yeah.
Why, I got...
What did you get?
I got 1.010.
0101. Okay, let me... What is... I swear it's my calculator. 0.08, right? 08
Yes. Minus
point
Mhm.
07
Mhm.
equals 0.01 divided by, right?
Divided by
Point
0.0099.
9 equals, my calculators give me 1.0101. Something screwed up with my calculator.
No, that's what mine says too. But the answer says 1. Oh. Hold on.
Yeah,
Let me.
I feel like I've been doing stuff right, but the calculations that come up are different than the ones that I have the answers for.
And
What
sometimes it happens when I'm working through the problems in the book, like the chapter, and so I've told her, and she's gone over some of them, and sometimes the book is just wrong.
Oh, you know what? It is. The answer really is 0093 because if you do divide it by 0093, that's what you get.
Okay,
1
so
point.
wrong.
No, then I get 1.075. Yeah. Yeah, see, my math, I could not get it to work the way they did.
Well, I mean, we're doing it right. I don't know. This class is frustrating me so much. My grade went down because of that freaking test.
But I bet you still have a high A, I mean a low A or a high B. You're probably doing great.
Yeah, you're working with two other perfectionists, so we can relate to you. When I first started this class, I was like, if I can see, I'll feel really good. But then once I got going,
That's I feel
mad.
like I really understood it. What?
Okay. See, that's where, let's see, let me try it again. Clear that.
Okay, I'm going to go back and do
The standard deviation?
Yes.
Yeah, I did not get the answer they got. We're going back to the standard deviation 9A.
No, the group quiz. What all have you done? So I can be on the same page.
I don't know, we're not there yet.
Wait, I thought you said that you started the group.
We
quiz.
did, but we got confused, Katie. That's why we backed up. Because it
I
wasn't
think it's because there might be things on the online textbook that aren't on.
Right.
That weren't on the.
When you were on campus, were you able to get onto the textbook?
Okay.
Katie, when you were online, were you able to get on the textbook?
0.07 equals times 0.07 equals. So on the top part, Pam, before you divided by 750, did you get 0.0651?
I hold on.
Because my number is way weird. I think
Yeah, the standard deviation I don't get.
Hey, is it working?
What do you
Hello?
Great. I think it's my phone. I think my computer's something is wrong with my calculator.
Okay, well let's. You guys want to go back to the quiz? All right.
Weird.
Monica, you ready for the quiz?
Yeah.
I know.
It makes me mad.
I know, it makes me mad too. Okay, we can always save it for later and then go back and figure it out.
Yeah, my answer for that P, I can't get anywhere close to 0.0093.
Yeah.
I don't know why it's so weird like that. Maybe it's just wrong. This lesson's a mess.
It really is. Okay, so question number 3. In a pie chart, why are the slices different sizes? And we put each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
Yep, that's what I was putting or was thinking.
Okay, and what do you think, Katie? What do you think on number 4?
It's the difference is that the Pareto charts are ordered largest to smallest, going from left to right.
Right. Okay, number 5. We conclude that P is normally distributed if, there's the equation, is P the true proportion or the sample proportion? We
P is
put,
a true proportion, right?
right, yeah, so we put 2. Okay. And then what is N?
Sample size.
Right. Number 7. If P equals 1/4,
Wait, I can't hear you.
if P equals 1/4, what is the smallest N that satisfies the requirement? We were kind of confused on this. I think it's 4, because if P is 1/4, the smallest that could be satisfied is. Actually, it could be 2. Maybe it's 2.
I don't know how to. Is there like an equation to or like? I don't know. That one's confusing to me. Because I don't know if sample size would really be determined by 1/4 because this parameter means like 1/4, but like you get 1/4 of any number almost.
Right. So, where's the smallest N that satisfies?
But maybe it is 4.
Well, I don't know. In my thing, it could be, it's a proportion. So 1/4 could be one part of the equation, and the other part could be 75%. So I'm thinking.
I don't know. I guess it would be 4. That's like all I can think of. I don't know what else it would
Yeah.
be.
I don't know on that one. I think I need to go back and read some more.
Yeah. Okay. Use the following information to answer questions 8 and 9. Suppose N is 24 and P is 0.4. What is the mean of sample P, hat P?
0.4, right?
That's what I think.
That's what we put.
All right.
Okay. Okay. What is the standard deviation of hat P?
All right. So that would be 0.4 times 1 minus 0.4. I'm so scared about these calculations. They always seem to come out wrong.
Right.
That's what's happening with me, and maybe I should just try timesing 5 times 5 and see if it works out, because I swear. Okay.
All right. I got 0.1.
Yeah, but then you have to square root it, right?
No, I did. I square rooted 0.01. Then I got 0.1.
Right.
You're right. That's what we got too.
That's what we got.
0.1. Okay. Use the following information to answer questions 10 through 13. Brittany's batting average is 0.3.
Josh,
We want to determine the probability she will get more than 35 hits in her next 100 at-bats. So, what is sample P?
P hat is x over n, right?
Right.
And then x
Is
is
X in this one 35?
no, that would be n. Wait, n would be what? It said x is the number of individuals with certain characteristics.
Right. I don't know. I think it's 0.3 because it says what is P, and it says Brittany's batting average is 0.3. So
Well, we're looking for, well, for that question, we're not really answering that question up on top, but the question is the z-score for that. I mean, number 12 is really what we're looking for to answer the question that's at the very top.
that's what I agree. Right. The probability. We do need a z-score for that.
Yeah.
I just remember the video saying that p hat equals x over n, and it said x is the number of individuals with certain characteristics.
Right, and so they want to know how many hits. I don't know.
Well, the z-score would be easy to figure out. The z-score would be 0.35 minus 0.3.
Yeah,
Yeah, that's before, but you didn't think it was right.
The example they used in the to find for p in one of the in the video, it says
P2 by P.
it says what is the probability that 172 86% or less college students in 200 send and receive text messages. Remember that from the video?
Right.
They used p hat was 0.86 and p was 0.8. And so in this situation,
It's 35 out of 100, so it'd be 0.35 minus 0.3, right?
Right. And that's what we did originally. So we've got 0.05 over 0.0458.
So what is p hat then? Hello?
P hat would be 0.35.
0.35. That's what I would guess.
Where did you get 0.35?
Because we put the 35 over the 100.
Yeah, we want to determine the probability she will get more than 35 hits in her next 100 at-bats. So that'd be 35 over 100.
Okay.
And so it's the p hat minus 0.3, so it's 0.05 over the standard deviation, which we got as 0.0458. Well, it was longer than that. I wonder if I need to go back and put it in. Let me go back.
Sorry, I'm getting the standard deviation now.
Okay. So for
What
my
did
score, I got 1
deviation?
point.
What did you get for standard deviation, Katie?
I got 0.017. Is that wrong?
I got 0.05458. Well, it keeps going.
I got .046.
Well, yeah, because we rounded up. But because you're not supposed to round until the end, I went back and redid it.
Uh-huh.
So I could have the whole number when I did my z-score.
Right.
So for z-score, I got 1.091. But I used the whole number, not rounding up. For the my standard deviation, I didn't round up. I used the whole number. So Pam, go back and tell me what you get for your z-score.
I don't know what I'm doing. Why is mine so off?
But my z-score is not going to work if I have the wrong standard deviation,
No,
right?
but use the standard deviation we got. I used this. You and I got the same standard deviation. I just didn't round up.
Okay.
When I did. So if I were to answer that question that asked for the standard deviation, I would put 0.045.
Wait, but to get
0.046.
wait, to get the z-score though, I don't even need the standard deviation.
Yes, you do, because it goes on the bottom of the z-score.
It's where?
That's
The
what
Z-
the bottom of the z point. To get your z-score, you have to do 0.35 minus 0.3 over the standard deviation, right?
To get your z-score, you have the probability hat minus probability divided by the square root of...
Right. That's
Yeah,
the standard
that's the standard deviation.
Oh, okay.
Wait, so why am I getting 0.017?
I don't. Katie, tell me what you did.
Yeah, tell us what you did.
0.03 times 1 minus 0.3 divided by 100.
Okay, so do it step
Square
by
root.
step. So 1 minus 0.3, what did you get?
I think I knew what I did wrong. I might have put 0.03. That's what I did wrong.
Oh, okay.
Okay, so Pam,
Yeah.
are you working out your z-score?
No, I will right now. So I have to write this down. So the z-score is so you put 0.35 minus 0.3 divided by 0.04. I'm gonna put 0.046, but you did the long number, right?
Long
Okay, I got the right z-score.
Okay.
Okay, so let me see. 0.35 minus, well, which is clearly 0.3 equals 0.05, and then divide that by 0.046, enter 1.086 or 7.
That's what I got.
Is that what you got, Monica?
1.091. And you got 1 point what?
0.87.
Well, let's see the difference in the probability, because now we need to go into,
Applet.
and I don't have my applet open.
I got mine here.
Where do I go to open it? Help me find the applet. I can't remember where to find it.
I thought you had it bookmarked.
Oh, I do, but that's in my other thing, but maybe I can get to it. Hold on.
You can always go to the test from last week and it has a link to it.
I can't find it. So let me go to last week.
Mine is not. Katie, did yours open?
Yep.
Mine looks just like the textbook. It won't open.
Oh my gosh. This is ridiculous.
So what do you get? It's greater than, right? So it'd be just right-tailed. So what's the answer you get? You just tell us the answer and we'll put it in.
Okay, 1.087, right?
Mm-hmm.
The area I got 0.1385, so 139. I'm gonna have to check all these. I'm not super confident. Also, I feel like the teacher might send out an email being like, "Oh, sorry that nothing's working in this
Right.
mess."
More than. So that was the right tail. Right tail only, right?
Yep.
Okay. 0.139.
This is making me crazy.
Me crazy too.
I hate this class.
I know, it's so hard.
Can you have her shut the bathroom door?
Yep. I tried opening up my applet twice. I got nothing.
Can
I
you
went to iLearn and I went to the.
give me the name? Like, do you have the www where? I mean, what is it? And I'll just type it in.
It's pretty long.
Oh.
Yeah. What I did is I went on to iLearn and I went to the Unit 2 exam and it says the normal probability applet and it has a link that goes to it.
Week 2 or unit or lesson?
No, the
2?
exam that we just took.
Oh.
You know how it comes up and it says you have 4 hours to complete this exam and you can use these resources. There's a file that goes to the normal probability applet.
I'm going to try that too. Oh, cancel that. I'll just save it.
Okay. Okay. Okay, so I see where, gosh, this is frustrating because with mine, if I put in my score, oh, it came out about the same point. No, it didn't.
No, I can't get the applet to open.
Okay, I have mine open, and so I got the same thing Katie did if we use that score. If we use the score from the whole number, though, it changes it. I can't right now.
And that's probably where you're getting the different answer. But since, I don't know, I feel confident using just the 3 decimals place because she asked us beforehand to round to that number, and then, so I think it's okay.
Okay.
And you know what, you guys, I'll turn mine in, and then you guys can keep going and figure out what you want to do. And I'll tell you what I got right and wrong. But let's get through this. We have 3 more to go.
Wait. So for the z-score of 1.087, right-tailed,
Right.
I'm at 0.1385.
Right.
Yep.
Okay.
Which is 0.139. Oh my gosh, I need to get in the shower. I'm so dirty. Yuck.
Sorry. Okay. Sorry this is taking so long. Okay, number 14, right?
Right.
If the true proportion of people who support the political candidate is P equals 0.52 and N equals 2,000 people are surveyed, We want to determine the probability that the results of the survey will suggest the candidate is losing the election, so getting less than 50% of the votes. What is the standard deviation of P, round to 3 decimal places?
What? But he's not losing the election. He has 52%.
But they want the probability.
Of him losing, I don't. It doesn't matter. Let's just do the math.
You can use wipes in my bathroom. Okay. So
Are you guys still there?
no, I'm not. Yes, I'm here, but I'm not
Yeah, I'm not getting it.
getting it.
You're not getting the standard deviation?
Mm-hmm.
Well, P
Isn't
hat
it?
was P hat. Is it?
What?
50?
Well, if you're looking for the standard deviation, you don't need to know what p hat is.
No, but the question 14 is what is the standard deviation of P hat?
Yeah. And so that's 0.52 times 1 minus 0.52 divided by 2,000.
Okay.
What? You want to determine the probability that the results of the survey will suggest that the candidate is losing the election.
What are you confused about?
I hate story problems personally. The wording, I feel like I can understand the information, and then when I start reading the wording on tests, I feel like I think I just make it harder, and it just seems so tricky. And so that's how I'm feeling about this, is that sometimes
It's just asking you the probability that it will be less than 0.5.
All right. All right, I'll figure it out. Let's see. So the standard deviation would be 0.52 times 1 minus 0.52 divided by 2,000. All right.
seems wrong.
I know. It's just something's not right.
What do you mean? I don't understand why you guys are confused. It's exactly like the other one.
Deviation. Katie,
What?
what number did you get for the standard deviation?
Probably seemed to compute it wrong, but I got 0.011.
Well, that's what I got.
Okay, good. Here.
Ugh. What?
Well, because it wouldn't be very likely, so that makes sense.
Okay.
So you're going to have a really... Okay, so then the z-score...
See, even 17 says, what is the probability the survey result will show the candidate is losing, even though the true population, thingamajig, whatever it's called, is 0.5. Yeah, winning, but they just want to know what the probability is of them losing. Okay.
Ugh.
Well, it would be 1
Okay, wait a minute. What did you guys get for the standard deviation?
0.011.
hold on, I didn't get that. Okay. When you did the 0.5, before you did the square root, what was the answer that you guys had?
Like
Yeah,
0.01248, something like that. Is that
that's what I got too.
Why am I being so weird? So you did
minus 0.52 equals what? 0.48
0.48 times that by
0.5.
0.52
equals 0.24
2496, and then you divide that by
by 2,000 equals
What'd you get?
0.001248
okay.
square
Okay.
root.
Right, mine. Oh, point. The answer is point. Mine gives it in scientific notation. 0.00030124.8. Right.
Yeah, right.
All right.
Okay.
I'm just gonna have to.
The root of that.
Okay.
So did you get it yet?
Yep. Thank you. Thank you for your patience.
No.
Okay.
We're good. But then do the z-score, which is
0.5 minus 0.52.
Okay, so the z-score, you set that up to look like. Do you put the 0.50 in front of the 0.52?
yes, because it's going to be negative. Because
It's going to be negative.
Yeah.
Yeah, it's always p hat minus p. It doesn't matter what one's bigger, which one's smaller. It's always p hat minus p.
Okay. So then it would be 0.52 minus 0.50.
No.
No,
P
it's
is 0.52.
our probability. What the question is the 50%.
Right.
So that.
Okay, so that's our sample. Got it. Okay. Okay, I got a negative 1.81 or negative 1.818.
Yep.
Is that what you guys got?
No. I don't know what I did wrong.
What did you get,
Okay.
Katie?
I got negative 1.818.
Okay, 0.05. Oh no, it's 0.5. That's where I did it wrong. Sorry. 0.5. Yes, negative 1.818. And then we put that into our, do we have to put it into the applet?
I think for the last question, yeah.
What is it even asking in 16?
I think it's just asking you if it's less than or greater than.
Oh.
Weird. I don't really understand what it's like why it's asking it that way, but I don't care. Simply do not care enough.
So what?
Because it says what probability do you compute using normal probability applet, and so that means
0.035. If it's just one-tailed, because we want it less than. Wait. What do we do with our applet? Let me come back and read the question.
It's less than 50%, so less
Okay,
than,
so it would be left-tailed, right?
Right.
So the probability is 0.0345. Is that what you got, Katie?
yeah.
Is point what?
0.0345. Whoops, wrong.
Or just 0.035.
Yeah.
Oops, you're right. All right, you guys, you want me to submit it?
Okay, wait, and 16, the probability is less than, right?
Yeah, that's what we thought. If you really want to submit it, go for it. I'm gonna watch people's videos and try to
I
get
think
that.
I will too. All right. All right, so I'm going to stop the thing and we'll keep working on it.
Okay, perfect.
All right, good luck, ladies.
Hey, good luck today.
Bye.
Sorry, it's a crazy day for you.
Yeah, well, no, it's all good. I'm heading out of town, so I have to get it done before I leave.
Oh,
so.
we haven't talked about our
Oh, yeah.
project.
Yeah, any ideas?